In previous episodes, you've heard Peter and I talk about different design patterns such as the Facade pattern and the Strangler patterns, which commonly relate to API design. But there are more. Have you heard about the anti-corruption layer pattern or the gateway aggregation or the gateway routing patterns? Well, Peter joins me once again today on Cloud with Chris as we enter another episode into the series of architecting cloud, one pattern at a time. Hello and welcome back to another episode of Cloud with Chris. You're with me, Chris Reddington, and we'll be talking about all things cloud. Now, as we mentioned in the intro, again, we've got another in this architecting series here, and we're going to waste no time at all and jump straight into the content as we've got a lot of it to cover today. So at this point, I'd like to bring in my friend and colleague once again, who I'm delighted to welcome back here, Mr. Peter Piper. Hello, Peter. Good morning to you.
Good afternoon, Chris. How are you doing?
All good, thank you. And yourself? Doing
great. Thank you for having me again.
Oh, very welcome. Glad to have you back. So as we mentioned in the intro there, we've... It all started a while ago, I guess, talking about API design, going and moving forward onto some various API patterns that we might be using. And we're going to talk about some more here today as well. We're on a journey.
Yes. These design patterns may not, the names may not come to mind, but the problems or the areas that they address usually come up when customers go, or individuals or industries or businesses add additional functionality, or they migrate, or et cetera, et cetera. Yeah. API is the core, one of the core components or layers within typical applications that you see out there in the industry.
Gotcha. So I think there were three that we were going to talk about here today. So the anti-corruption layer, the gateway aggregation, Correct. And the gateway routing patterns. They all sound really fancy. You know, they
do. I know. And that's why the name is like, oh, that doesn't really resonate with what I'm trying to do.
Exactly. So I'll switch over to the screen and bring that up here as well. So I can see you've got the Strangler pattern on, actually. So does it make sense for us just to reset first and make sure everyone's on the same page and then go from there?
I think so, because this, to set the context, is key. And so just so we could understand the Strangler and from a visual perspective. So let's say you would want to modernize and migrate from a legacy system to something much more modern. And in our previous sessions, we talked about moving from a legacy to a modern and what kind of considerations and things you may want to think about through this Strangler pattern. And what does that journey look like? And so just from a visual context, I wanted to ensure that your viewers understand this is where we're starting and how do we move into the anti-corruption. For example, where will we implement anti-corruption in this early to later migration phases?
And just for anyone who's listening in, not necessarily watching, the diagrams we're looking at here as well are on the Azure Architecture Center. So there's a pattern up there relating to the Strangler pattern. There's a nice diagram from the left thinking about that legacy deployments and eventually strangling those deployments out and removing piece by piece, chunk by chunk, into a more modern deployment. So just in case there, it's definitely worth a look through because these docs are very, very good. Good. Okay. Yeah. So you mentioned anti-corruption layer. Yeah.
Correct. Yeah. So visually, let's think about this as we move to the anti-corruption. The anti-corruption layer and pattern here within the documentation, it goes to the same kind of process we've gone through before, understanding context and problem. What are the solutions, issues, considerations, when to use them, or what's the anti-pattern or no-op situation, etc. And as usual, there's a great diagram here. So let's jump in. Is there, you just want me to jump in and we continue, or is there something you have top of mind? Because your viewers, your listeners, they may submit comments, etc. Have they? Is there something there?
I think let's try what works well with some of the other sessions done is let's think about the story between the these few different patterns that we're talking about. So we've got some backend APIs. Maybe we're like a retailer or a bank or something like that, and we're now thinking about these anti-corruption. So how would it help us maybe in those scenarios? Why would we consider using? What might be the things that we might not consider using, for example? Perfect.
And so the diagram, when I first view this diagram, I always think of an enterprise service bus or an ESB.
Yes.
Every time I see this diagram, and this diagram, just to let you know, is not just within our docs, but it is within other docs. And they go through different areas here in this particular doc, and then within our domain-driven design, which is in where this anti-corruption starts from. It comes from a domain-driven design. And so you have different microservices, which is a domain. And then you have a newer or a backend service. So the reason why I bring in the Strangler pattern is as you move to a microservice or domain-driven design, which is here, you're moving from legacy to a modern, you may encounter situations where I don't want to reveal some of the business processes or, in essence, my back end data models. Think of like typical object relational mappers or ORMs. So the other thing that comes to mind in my head is interfaces, abstractions, and then these concepts called DTOs or data transformation objects and DAOs, data access objects. That hot potato swap. And I've seen systems where it works and it works beautifully and it's a layer of abstraction. And then you could create mocking for testing, for performance and injection using dependency and inversion control. You could go into all different areas, but let's set the stage. What are we doing here? And that is, so we do not create corruption as we are going through a migration of a legacy-based system to a newer based system. That's the ultimate context. And so, as I was mentioned earlier, developers, development shops, they most likely implement this to some degree, so they could have high cohesion, low coupling as the center stage, which is the message I've been delivering, I think, almost since the beginning.
Absolutely. I may have heard that once or twice, and viewers may have as well.
Just maybe once or twice, yes.
Gotcha.
And so examples, right? Let's say you have a subsystem B here, and it is a REST-based or a SOAP-based system, and these microservices may be REST-based. Oh. So the anti-corruption layer will do that translation for you. Enterprise service bus concepts. Yes, that makes sense, right? But you have to transform between the microservice and the subsystem, right? That anti-corruption layer has to have some elements of transforming that.
And I guess then what we're kind of implying there then as well, and maybe I'm skipping ahead a little bit, so pull me back if I need, but is this idea of a contract between those two systems as well, right? That this is what the one is expecting, this is what the other's expecting. And is that what we're talking about when we talk about corruption in this sense? The fact that they're almost talking that consistent language?
In essence, it addresses that consistent language, but it allows a safe versioning framework. Right? And so there's operational contracts and data contracts. And so that's what I usually call that hot potato swap, right? How does an older legacy system, which may not have a versioning model at all, and your microservice may implement a versioning strategy, right? Because if we think about the Strangler, you're moving from legacy to a modern. You will want to incorporate versioning within your microservice. Probably early on is the ideal. Some shops, some customers, they go, I'll just presume the first one's V1 or some number. And so there are issues, scalability, and other things that we definitely could go into in terms of, because I know we have other design patterns to discuss. And so we could go through that. Is there anything top of mind that you definitely want to ensure we address?
I guess what I'm trying to discern maybe for viewers and the listeners is the difference between something like the Strangler pattern, the anti-corruption layer pattern, because if I map these patterns into more technologies, then maybe this will help anyone listening and maybe making it a bit more concrete. Both of those, I think, cover something like API management, for example. And I can see maybe it's API management as a service solved both of these problems separately. It's just these are two separate problems, but it so happens that API management's both of them. That makes sense.
Sure. And think of design as separate from implementation. Right. In most development shops, when I first started to review some of the design patterns, I was like, oh, that's implemented through AutoMapper, or that's implemented through this. So I don't really need to worry about the design. But ensuring this understanding problems, understanding challenges, understanding what has what I would call prior art exists in a development landscape. Right, because we've been writing code for close to 100 years, give or take, to some degree. So understanding there are things already in place that address these situations. And if you want to understand a little bit more about domain-driven designs, there are tons of resources. For example, this is an older article, and it talks about what is an introduction to domain-driven design. And in here, this article goes into more of the actual implementation to some degree, and it provides some tidbits. This other anti-corruption layer document, while granted it's not within, it goes through how do you create interfaces? How do you create your operation contracts? How do you implement versioning and those type of things? And what is the adapter?
Gotcha.
So the anti-corruption layer supports much more than just a design. To your point, Azure API management, to be specific, has policies built in to support probably, I would say, 99% of use cases.
Indeed.
Give or take.
And it's
right.
Because, I don't know. I was about to say, I think that explanation helps actually, because I now get what we're saying with the corruption side of things. It's that modern, if we think about that older diagram again, Strangler path. We've got the legacy application, the modern application. What we're saying is, as we go along that journey, maybe the early or the later stage, we don't want our previous design decisions to influence the new shiny stuff that we're building. We want to keep that new and shiny, make it easily swappable out. That's what we're talking about here, isn't it?
Correct. Yeah, and it ties in with the facade. And so, as I was describing in the previous episodes, when you move business rules, maybe you say, I want to code reuse this into the modern. What if the thing you are or the code base that you are going to be bringing over is a legacy security based? And so how do you ensure you're not introducing not just technical debt, but attack vectors? So with each of these design patterns, still continue to keep security top of mind. Would the anti-corruption layer have an extra layer of security baked into it? Is that required? Right.
Gotcha. And you mentioned the R word there, so we'll call it out. It's always depending upon requirements, right? I think over the past 2 episodes that I've now recorded with Steph and Will, by the way, they've both somehow naturally come to the same conclusion, which I'm sure we'll reach at some point throughout this session as well, that there is a time and a place for all these patterns and they make sense, but use them only if your requirements drive you. If there's no necessary reason to have them in there. That's maybe where you then start entering the issues and considerations like I can see it bringing up on screen, and adding extra complexity in architecture as well, which is not what you want to do.
Definitely. Issues, considerations, quick ones, top of mind, performance. Any design pattern, any layer of abstraction will add complexity, will add latency, will add some elements of that will negate. So you need to ensure, first and foremost, what is the additional code base that is required to implement such pattern? What is your application development lifecycle? The estimates to support it. So, for example, if you're going to do a swag from a DevOps, right, or DevSecOps mindset, and typically without a design pattern, you could knock out code base through hook and crook or whatever phrasing you may want to have is an hour. Yep. Adding this design pattern, would it add 3 times to it? 3 hours, 4 hours, etc. The other considerations is monitoring. What does this mean to your release processes, right? Because you are still within the context of either this migration or this Strangler. What does this add for a release through ensuring the facade? So how are you going to have performance and load testing? Ensure you have a framework or an approach. Iterate over your approach if it doesn't work out. And remember, you are behind a facade. So technically, you could kind of have a blue-green and roll back to support any kind of hot fixes, silver bullets, whatever phrasing you may want to have. Then the last thing is, when are you really going to sunset? When are you going to just retire that legacy code base? And what will you be doing through that disposal of that code base, right? Because that is technically, you are finished with that technical debt, and ensuring the new code that you are bringing in may not add too much to technical debt. Obviously, with this kind of anti-corruption layer, if you have one microservice to one backend service, adding a complexity of an anti-corruption layer just for 2 components to speak to each other may not be the right place when you want to use this pattern.
Gotcha. I guess if we're decomposing a big monolith into multiple microservices like that diagram was giving, that's a good kind of example. But as you say, 2 completely isolated components that just need to speak to each other. You kind of touched upon it, and I really want to pull that nuance out around DevOps. Always need to keep the end users in mind, and the way we prioritize our work, is it delivering value for our end users? In that scenario, it's just adding complexity for the sake of complexity. There's no real gain, there's no real value. So why?
Right. And to circle back on that, this is a design, right? Then you could go up to architecture or principles or tenets. There's a you ain't gonna need it, a YAGNI principle, meaning you are designing for the future, but if that requirement doesn't exist, you're not adding value.
Good. No, I think that makes sense. So then, does it make sense for us to look at the gateway aggregation pattern?
It definitely does. And so if you think about these microservices, let's set the context again. And the backends for front ends comes to mind here, if I remember right. And this is where you say, hey, I have N number of services that are used by a particular application. Let's say a company is trying to create a mobile application. I'm going to still follow this kind of diagram, an N number of services. However, you're going to have certain things that are constraints inherent to any kind of platform, any kind of device. And so the constraint can be power, radio usage from a mobile phone, transmission, the amount of bandwidth that's available, etc. So you will want to move from this type of diagram, and that is an application just directly communicates with N number of backend services, to a solution that you have a gateway. And the gateway will then consolidate and submit the requests to those backend services. That being said, there are additional design patterns or considerations you may want to think about when you move to this. So before I go into some of those nuances, is there something that you, Chris, may be considering of either exploring?
No, I think that makes sense. I think, what we're talking, it's fortunately one of those patterns that does what it says, right? It's aggregating a load of back-end calls from the gateway rather than having your application need to go and directly make. It's taking some complexity away from the application. I'd even bring it back to that microservice scenario that we mentioned earlier as well. How often do we find when we're building microservices that, hey, I'm not just querying one particular microservice, but I need to speak to my account microservice, my inventory microservice, my, whatever other microservice. There is always that kind of slight stretch that I need something else. And it seems like this might be where I have this kind of wrapper for my API operations, and I obfuscate the backend to my application.
Correct. Exactly. So here's some things that you may want to consider this for. Let's say you have bulk or batch operations. And because of the constraints that you are as you move into a particular device, mobile strategies, or anything like that, this will be a good place to do that. Instead of having a mobile app being chatty, it is consuming, like you're polling a service every 30 seconds. You are submitting a request on I call it a radio, because in fact, on a mobile device, it's a radio. It sends and receives, right? So, and it's on a frequency. So that being said, if it's sending something every 30 seconds, that's 2 calls a minute. And that could consume, 0.01% of the battery. But over an hour or over 5 hours or over 6 hours, what does that really do? And your application is probably not the only one running on that mobile device. So think of, how do you combine a request to talk to multiple backend services or bulk operations to do an operation? And the reason why I suggested earlier, this is going to introduce and enable other patterns you may want to consider. And that is the one that we talked about, backends for front ends, to support when do you use this particular gateway aggregation. Then if the gateway is going to be performing these operations to those backend services, then you have to think of the async request reply, claim check patterns, which we're not discussing on this call.
But actually, by the time this one goes out, Will's episode where we talk about asynchronous request reply will be there. So there's a plug for that session. And we did a plug for this session as well in that one as well. So lots of plugs going around.
Correct. And so it adds complexity. However, you are addressing a core fundamental response to a challenge or a constraint.
Sure.
Right? And I'm going to continue of bringing back this message. Think of high cohesion and low coupling, and don't couple to the aggregation, the gateway aggregation service. Right, your application's communicating to here. Think of still interfaces or some kind of abstraction. And I'm for listeners, this is the diagram between application and gateway. There is some communication there. So you definitely want to have some methodology to have a great scenario for having integration and regression testing, right? If your gateway version changes, what happens to the application? Can you mock the gateway service? Now, as we move into the issues, performance, right? We're adding another layer.
Yes.
It may add latency. You definitely want to consider moving this gateway closer to the backend services, whether that be on a network or subnet or some kind of to reduce not just the network latency, but just other operations. In issues and considerations, it brings up additional design considerations. So the other thing that you may want to consider before I scroll down into here or move further is versioning and security, right? Application's going to be not speaking or communicating directly with the service. Now you are adding a gateway. Where is security?
I know the answer to this one. You shouldn't leave out either or, right? Because, and this is something that we've had some fun debates on between ourselves and our team here. But for anyone listening in, if you think about this now, this is a really important point to understand here. If you just implement your security at the gateway level, right? Cool. Any requests going in through the gateway, you're validated, they're secured if you're doing authentication or authorization or whichever. But what happens when you accidentally publicly expose that backend service on a public IP address? Or what happens if you've got a malicious internal actor and you haven't got that layered defense? So consider all those scenarios and bring it back to the... I'm sure Peter will have some additional thoughts there as well. But yeah, that one gets me really animated, as you could probably tell.
Yeah, definitely. And so if we look at the diagram for the application and these services can be three public endpoints. Yep. That's a big surface area. So you have multiple attack vectors. So when you start going, okay, yep, I could address security by, to your point, putting it in the gateway and everything becomes back internal. Great. At least you reduce the surface area from 3 to 1. However, if you have either been compromised through another public endpoint or the gateway gets compromised, you have no way, based upon your implementation, to either recover or do something like that. And so before we can leave the security conversation is work with the business, work with the your security or InfoSec teams to say, hey, can we do a limited or some concept or conversations around threat modeling?
Yes.
Granted, within Fast Track, we may not do that to some degree. However, we bring that up to awareness to our customers to say, hey, there are things within the MITRE ATT&CK framework, such as lateral movements. Service 3 could be easily compromised because you didn't put security into it, or you put it out as an MVP for proof of concept, didn't bake in robust security, but Service 1 and 2 are a little bit more mature because of the versioning, the security, and those kind of things. What happens? They could be compromised too, because guess what? Service 2 wasn't thinking, hey, there's somebody behind me that should be trusted. So there are principles, least privilege and zero trust. There's so much in there, but think through your versioning and security. What are your requirements? Ask questions, and you will not have all the questions to ask because you don't know what you don't know. But work through different scenarios. Happy path, exception path.
And the way I always like to play it, and before we move on here, is asking the blast radius. And I always call it blast radius because you can interpret that in so many ways. So what's the blast radius of Service 3? If Service 3's credentials get compromised or they reach elsewhere, what's the blast radius if Service 3 is deployed incorrectly by using the same shared ARM template or as code? What's the challenge if we don't have the authorization on the API layer of Service 3? What's the impact of that? And leaving it that quite generic question makes you then think about it in different ways. And, blast radius. Always think about what happens if it goes wrong. And the final one, actually, because I think both in Strangler and the anti-corruption layer and this pattern, and probably the next one as well, I suspect, we're also introducing a facade. And if you think about blast radius, we're introducing a potential point of failure. So what is the blast radius? What goes wrong if that facade layer goes down, if that intermediate layer goes down? And how does it impact the application? Because as always, once you add more components, you are impacting your overall SLA in your solution. So just consider that as well. I'm not, this is absolutely not me saying don't use them, because you shouldn't use them at all. But you just need to understand the trade-offs that you're making. And that's always what we're thinking about with these architectural patterns and these decisions we're making here.
Exactly. And so a plug for one of your other sessions on DDoS.
Yes.
You as a customer may be going, I'm going to move to the cloud. There are threat actors or bad actors that are using the cloud for DDoS. How do you recover? Are you aware of what those implications mean to you, right? So as you move through that. So I know we could talk about security forever, which is awesome. However, just making sure you are aware of certain considerations with respect to not only the design pattern, the levels of abstraction that you are introducing in any kind of design pattern process in your software development lifecycle for your solution, but your security, et cetera, et cetera. So just like in anything else, monitoring, right? In each of these abstraction layers or each of these components, right? As you move from a Strangler pattern using a Facade from legacy to modern, what is your monitoring, logging, alerting strategy as you continue down this path? And how does that align with security? Same thing for anti-corruption. Where are you going to be putting monitoring? Do you, if you put monitoring on each microservice anti-corruption layer database, is that enough or too much, too little, right? Work through that. And when do you need to be notified and to either identify a issue that has to be addressed, a microservice being down, the anti-corruption layer down. If the anti-corruption layer is down, what does that mean? So as you move through this design pattern, start thinking of chaos engineering. I know you probably have somewhere earmarked in your beautiful brain there. Where do you implement chaos engineering? And if a service is down in production, guess what? I've been in a particular shop and something was down in production. I'm like, let's test some other stuff. While we're trying to resolve this, not everybody's on resolution. Test these other functionalities, see if they're broken. What happens? And so the reason why I bring that up is you are going to probably some point incorporate what they call resilient design. Where do you use bulkheads? What sank the Titanic? The bulkhead didn't go all the way up.
Yep.
So that being said, where is the isolation, not just from noisy neighbor that the cloud introduced? Where are you putting bulkheads to ensure the whole ship doesn't go down?
Yes.
Where are you doing circuit breaker and retry? And I believe you have end load leveling patterns and other things that I believe you've done. Caching, when and where? What are your failures? What are your business rules to be either less dynamic, more dynamic data? How long, right? So caching using Azure CDN, which is a global service. Guess what? Yeah, you might say that's expensive. I could just keep it in memory. Let's take a look. If you cache in API management, it has that capability, and it goes down. What happens? How do you rebuild the cache? How do you rehydrate? How do you know what state it was in? So as you continue to go through that process, then just trying to figure it out. Now, as I mentioned earlier, performance and load testing. You're adding another layer of abstraction, possibly through some kind of implementation. Think through your testing within and security and versioning, blah, blah, blah. So gateway routing, a lot.
Yeah, I think let's go to gateway routing, depending upon which side of the pond you're in, of course.
Definitely.
Yes, let's do that.
Yeah, so there's a lot in gateway aggregation, and it does tie into gateway routing. And so in essence, let's go bring up the diagram, right, which ties into the previous diagram. Think of how are you going to handle requests that is either being routed from many services to one endpoint. This diagram for listeners is similar to the other one, and that is you have a consumer of a series of data sources or a solution, and you have a search service, for example, order history service, reviews, carts, checkout. Think of e-commerce in this case, basically. How do you, and it's interesting, we've come full circle almost. As you work through your Strangler pattern of going from legacy to modern, great. Does this mean that you are removing the monolith type of model, going to microservices? Possibly, right? As you move into this type of diagram, are you creating a logical monolithic type of application or solution? Monolithic applications in the industry has been bad. But when you think about it, we have created a logical representation of a series of services or series of operations that address a particular need for a page. So your e-commerce page will have a banner, side nav, right nav, middle body, and it's a series of services that are going to feed into it. Mm-hmm. Yes, you could have versioning of each one. Now that adds complexity. When does each other service talk to each other? It becomes much more challenging. So how do you create a way to have efficient routing? A monolithic application from a design, great. It addressed things at the beginning. It allows MVP and POCs to get out the door very quickly, but you could break them down. And that's what the Strangler pattern is. But let's think of the routing. Right? Let's think of the routing when you start going into these series of services. What does that mean? Does that mean I can, because if let's say the scenario is each of these services, search service, I never versioned it. But my cart service, I might have versioned it because we didn't know the full requirements for what a cart has. So I can't search for a newer version of what's in my cart of the product, right? So, okay, how do we route from a search service v0 or non-version to a new one? So this will allow that routing to go, and you could say, I need to go to search service, or I need to go to search service v1. So the consumer is behind the facade, and it doesn't need to know that. Yep. So you're moving into what I am trying to describe is a layer 7 implementation.
Yep. Yeah, and I think there's, depending upon the scenarios that you're talking about specifically, up it again to technologies, just so people kind of getting the ideas. API management, you could argue, in a way, could deal with this. You could argue something like application gateway. There we go. That is a great diagram. You want to go ahead and walk through it, Peter?
Yeah, sure. So since we are dealing with efficient routing, we're using layer 7. You could route via IP, port, header, or URL, right? N number. However, you may not just have a web application. It could be UDP or it could be non-TCP traffic, basically. So this diagram is within our architecture guides for load balancing options available in Azure. And so the diagram has you are starting here. The first question is a very simple one. Is it a web application that is going to be over HTTP? Yes or no? And that's where it forks. There are various Azure services that do things based upon the requirements, based upon their design. So if you have the application is not a web application, for example, really simple, and it's not internet facing, Azure Load Balancer, right? You have SQL servers. They're handling SQL Server traffic in a cluster or in a load balance scenario. So you definitely use Azure Load Balancer. But as you move more and more into the web-facing world, you could use Azure Front Door Service and Application Gateway. You could use Traffic Manager and Azure Load Balancer or anything along those lines. But think of your layer 7.
We're talking things like Application Gateway, for example. We're talking things like Nginx. You could kind of argue potentially API management as well if you've got microservices that you're in the back end, but that wouldn't it wouldn't be something I would typically call a layer 7 routing load balancer there. I think it's a slightly different scenario where you could kind of map it to the pattern, but the others that we mentioned there are a better fit.
Exactly. Yes, agreed. And so just like with this scenario, you will have APIs and clients can continue to evolve independently. Yes. So high cohesion, low coupling, because this is still kind of behind that facade and that gateway service. Because think of it this way. Each client is not going to know how things are routed on the back end. So it is calling a header, and it's going to be saying, call the search service with a V1 through a query string or an HTTP header. The gateway services. I know where that needs to go.
Yep. And that's effectively what we're talking about with gateway routing in that kind of one succinct sentence, just in case anyone's still kind of going, okay, it sounds similar to some of the others. There's this facade layer still. And I think that's the key bit between all of these. If you're, thinking through all of the different patterns we've spoken about so far, they all involve this facade layer. Strangler has the facade in front. And the idea of the Strangler is you're removing that legacy, going into that modern approach. The idea with the anti-corruption layer, that translation between the old and the new. The idea behind the gateway aggregation, it's the idea of that facade acting as the aggregation point. And now with gateway routing, which version of your backend do you be going to? So the magic behind all of this is decoupling. I think Peter said it enough times. I'm not going to steal his phrase from him, but decoupling that front end and that back end from each other.
Yep. It does. This particular design pattern continues to enable ease of deployment, right? It's now could be an appliance, right? A layer 7 type of appliance. And so it may not be software driven. You can do routing, policies, etc. through infrastructure as code. Great. Awesome. Easy. Now, issues. When I look at this diagram, I'm like, single point of failure. Think of resiliency. Remember, as I was describing in the gateway aggregation, the anti-corruption, monitoring. What happens if that particular layer or that implementation that supports that design pattern goes down? In gateway routing, single point of failure. How do you implement or how do you place into your design resiliency to support high availability, business continuity, and disaster recovery? Performance. This is another layer. Versioning and security. Same thing. Then you will have to consider integration, regression testing, performance and load testing. If you say, let's say Nginx, great, it works great for these kind of applications, but it doesn't work great for these applications because of their payloads or whatever. Or it doesn't support a good security model or versioning model. Try something else out. So how do you have interchangeable implementation to support the design pattern? And so the takeaway for me is the design pattern is agnostic of the implementation. It is the design. So if we think of SDLC, you get requirements, architecture. Then you start thinking about design. Then you start thinking about development and implementation. And then it comes back. Monitoring, think of the DevOps infinity symbol, right? Monitoring and logging feeds back into the bug, feature request, improvements lifecycle. How do you incorporate integration testing, regression testing, performance and load testing in any of these design patterns? When to use it, consumers and their API consumption complexity. Your API management has capabilities. Your application gateway may have ways to understand who your consumers are. Think of security, defense, and depth through either a network abstraction or something like that, since we are at layer 7. Anti-pattern, similar to the other one, 1 or 2 services consumed by a client app. Do you need a gateway? Maybe you need WAF and DDoS, right? Web application firewall with some DDoS and some level of security there. Those are considerations. A lot to digest.
Indeed, a lot to digest there. So once again, thank you, Peter, for joining us today on this episode. So we've learned another 3 patterns there that really relate to the facade pattern and build upon it. So we started off with a Strangler pattern, which wasn't really in today's session, but good to touch upon. And then we started talking about the anti-corruption layer, the gateway aggregation pattern, and also the gateway routing or gateway routing pattern. So thank you for tuning in. Thank you for listening. And you know what to do. Please like, please subscribe, and please do share on to others. We really are trying to build the YouTube channel and pushing out more and more content there for you all. So if you have any ideas, if you have any suggestions, as always, please do let us know, and I will be happy to add that to the backlog and present more of this for you all. So stay safe, stay healthy, have a happy new year, and until the next time, bye for now.